Hi, everyone. I'm Stefan Halter. I'm an engineer on ASP.NET.
And I'm Safi Abdallah. I'm also an engineer on the ASP.NET team.
And we're both very excited to show you minimal APIs in .NET 6. So I'm going to start out with a demo. Today, I'm moonlighting as an engineer on Contoso Construction. I have been working on an app, a backend, to manage our construction job sites. And I've already written this app using .NET 5. So .NET 5 templates you may be familiar with have program.cs, where you set up your host, your startup CS, where you set up your application, and then you might have some sort of controller if you're doing a web API. And now I want to update this to .NET 6. So first, if we take a look at this edit project file, it's nice that we don't have to unload projects anymore. If I wanted to upgrade to .NET 6, I could change the TFM, the target framework, and go. And this would just run. But I want to do something a little more fun. I heard that .NET 6 introduced minimal APIs. And so here, I will create a new project that does the same thing and try this out. So without further ado, let's try out the new project template. So I'm going to add a project. I'm going to start out with the empty ASP.NET Core project. I'm going to call this my minimal server. And we'll choose all the defaults. So this template is quite a bit different than what you might have seen before. You'll notice instead of a program class and a startup class and these controllers, this is the empty template. So it wouldn't have had controllers before, but it would have had startup. And now we just have 4 lines of code. So you've probably seen a bit of this before. This is using our new web application host. And this is using the new C# features you heard about. So if we take a look at this CS proj, you'll see that we've started enabling nullability, implicit usings, and that allows us to really get down to the business logic of our application. Now, since we're porting an existing app, I'm going to copy these package references that we already have. We can install packages just like before, but it's pretty easy just to copy. And then from there, I'm going to go and I'm going to define our DTOs. So I'm going to add some jobs. And then we're going to be using EF Core to manage our database. And I'm going to be connecting to SQL Server and Azure. So to do this, just like we did in our original application, we're going to add Azure Key Vault to our configuration so we can pull down our connection string. So this is one of the new things in this presentation that you might not have seen. So in the past, you had this host configuration and app configuration, and you had configuration builders and iConfiguration, and you had to figure out where to use each thing. Now in .NET 6, our web application builder has a configuration manager. So this allows us to both read configuration. In this case, it's reading a Vault URI from my environment variable, and then add new configuration sources. So we're now reading connection strings from Azure Key Vault. And you'll notice that we're using the same configuration object to both read the Vault URI and add sources. So now that we have our connection strings, we can add the DB context for our jobs. And we're going to use the Azure SQL connection string I have defined in Key Vault. And now, instead of creating a new class to define a controller, I can use these new map methods. Now, you might have seen map get, map post, map delete, things like that before, but this isn't like what you've seen before. Instead of always taking an HTTP context and returning a class, you have a lot more flexibility, always returning a task. You have a lot more flexibility and a lot more options, a lot like you would in a web API or MVC controller. So if we want to define some endpoints, we're going to define the exact same list of endpoints that we previously had in our jobs controller. So before, we were taking our job site DB, which is the DB context from Entity Framework, as a constructor parameter. But now we're just taking these as a parameter to our request handlers, as we're calling them. But this is minimal APIs. And you'll see that if we want to get all endpoints, we can get our normal to-list async. So let's first set this as our startup project and make sure that we haven't we're good so far. So we're going to start this project, and I'm going to be testing this out with HTTP REPL. So we still have our hello world endpoint, so at least we started. That's a good sign. We're listening on 7204, so that's another change in our templates. We now are listening on basically random port numbers. So this means like when you do file new project, you don't have port conflicts. You don't have to go into your launch settings and change everything just to avoid port conflicts. And this is great when you're trying to do microservices where you're running a bunch of apps at once. So let's quickly get the jobs endpoint and let's see if we get some results. We're connecting to Azure, so this database is already populated and we see a bunch of jobs we have in progress. So that's a good start. But let's look at some of the new features we have. You'll notice that we're pulling in some attributes for when we're posting job bodies. So we're posting jobs as JSON here. So anytime you have a parameter that's from the body, that's being read as JSON. Here, the job site DB is from services. And you'll notice before, we took that without the attribute. So the attribute can be inferred. Basically, Minimal APIs knows that the job site DB is in your service provider. So there's no need to attribute it unless you prefer that for better clarity. Another thing to note is that these attributes are coming from MVC. So these are the existing attributes you might use today in your MVC controllers. They continue to work with these callback handlers.
Got it. So Stefan, you've shown how we could resolve the job type from body. What if we wanted to resolve some custom DTO? Like say we wanted to do a search for our job sites based on the coordinates.
Excellent question. So we already have this search based on a string that we had in our original jobs controller where we're searching the job site by name. But if I want to search in a specific area, we can use a new feature in Minimal APIs that allow you to basically define custom DTOs and determine how they're parsed. So let's see how this would look for like a latitude-longitude pair, which we'll call a coordinate. So we're going to define our coordinate DTO. And here we're using records, so it's easy comparisons. It defines all our equals methods. It's we can define latitude, longitude right here. I really enjoy those. And then the key here is that we have the static try parse method. So this takes input from either the route or query string, and then allows us to output our coordinate type. So in this case, we're reading two doubles separated by a comma, and that will be our latitude-longitude pair, which we can search by. So now, to use this in an endpoint, it's going to be pretty similar to our name search. But if we're going to define our coordinate endpoint, we'll see we have a coordinate here instead of a query string, and we're taking this coordinate as a parameter. And now we're searching for within 1 degree of latitude and longitude of the place that I search.
Nice.
So if we start this again, we got to restart the entire application because we're rerunning the program main method. So to rerun main, we're going to restart the application. Even if we could reload the code, it's not going to be called again unless we restart. And then let's see if we can't search for a location. And then let's search for around, let's see what we have here. We have basically around 47, negative 122. Maybe we'll find a few.
Yep.
We need a comma. Otherwise, it won't parse. We might get a 400. All right, good thing we can go back in my REPL. And do we have results? Nope, because I basically searched in the wrong place. But maybe it's not within a degree. We just deleted a bunch of endpoints to clean it up.
It definitely works.
Yeah, you got to trust us. So this is what happens sometimes when you have a live demo. Now, this works great for query string and route parameters. But say you want to read something from the body. That might need something that's asynchronous. You don't want to block your request thread. That's a big no-no in ASP.NET. So we also have the option of defining a bind async method. If both of these static methods exist on a given type, Minimal APIs will try calling the bind async method since it's more flexible. But because it's more than route and query string parameters, bind async doesn't just provide the string for you to parse. It just gives you the entire HTTP context, but you got some details about the parameter that the coordinate thing was. So we can take the coordinate name, pull it out of the route value, call try parse. Things work. So that's not all we have. So this is teaching us how we can basically handle different kinds of inputs in minimal APIs. And you'll see we also have some other special kind of inputs. Like in this case, you're taking HTTP response. This could also be an HTTP context. This could be like a claims principle, things of that nature. So we have these kind of special parameters. So that's nice. That allows me to basically, in this case, write a 201 created response. But I also have the option of doing like results.created, and then we can put in like our job or whatever, job ID. So I'm not going to write that all out now. We have some other examples, say here and here, that basically are a lot like the action results that you would have seen in the jobs controller in the past. So unlike with the attributes that are supported on the parameters, the action results that we're returning, like OK action object result and not found object result in MVC, those will not work in minimal APIs. So we designed this new results static class with these methods, and these return new iResult types.
Got it.
And this is new to minimal APIs.
Cool. So I see there's a ton of extension methods for returning 404 results or 200 OK or a variety of other result types. What if I wanted to add a custom result type for our application? Like say we need to return XML from one of our endpoints.
XML? What are we, in the year 2000? Fortunately, we did prepare for this, so I think we can do just that.
Perfect.
So let's try finding an XML result or defining an XML result and seeing what that would look like. So here we're implementing that iResult type that we had before, and we're using an XML serializer. And one thing that we're doing, right, serialize is an async, so we're serializing this to a memory stream because we want better scale. If you want even better efficiency, you would pool this. But this is taking an HTTP context and then writing this result, which is passed into the constructor, to the response body. And it's that simple. It's doing that asynchronously. And there's one other thing that I added here kind of sneakily, is this extension methods to iResults extension. I'm not even using this parameter, but all it's doing is calling this constructor with a T, and this is allowing us to discover these new results types. So let me show you what that means. So here we have this endpoint that is returning all of our jobs. And right now, it's just returning the object directly. So just like in MVC, you're allowed to do that. But if you have these custom results types, it allows you to do interesting things to the HTTP response, like change the status code, change how things are serialized. So if you return an object directly, it's always JSON. But in this case, we can do results. And in this case, I'm going to go extensions. So that's the iResult extensions type that I was extending with my extension methods, and then do XML. And because this is a method and not a constructor, I don't need to pass the T. So if all goes well, it's going to tell me that I need to restart the entire application, which is true. Anytime that we redefine an endpoint, you got to rerun main at this point. Certainly if you're adding an endpoint, that's necessary. So now it's running again. If I do a get, before we were looking at all the endpoints and it was JSON, and now we have XML.
Oh, nifty.
Yeah, so perfect for all of you guys traveling back in time. So this is what I wanted to show you as far as how to deal with the new minimal host, parameter binding, and this new results types. I hear that you got some stuff to show.
Yes, I do. We're going to switch over to me really quickly. I loved everything that you did in your demo. You showed a ton of interesting endpoints. And I want to take it a little bit further and try and document some of the endpoints that you have created here. So I'm going to go ahead and jump into my local clone of our application that we've been moonlighting and building and show you how I'm going to add support for OpenAPI integration to this app. Now, OpenAPI is a specification for documenting APIs, and we can leverage that within our minimal apps the same way we would in our controller-based applications. To do this, I'm going to set up the groundwork with a couple of things. First things first, I have registered the services that are needed to support generating OpenAPI definitions in my application. So 2 lines of code. Again, I'm using that web application builder type that Stefan was talking about a little bit earlier. And then I'm going to add some middlewares that are going to render a Swagger user interface. So the API that I'm going to document is going to be kind of printed out and displayed in this Swagger-based UI where I can explore all of the types and even send out requests to those endpoints the same way you were doing with HTTP REPL. So I've set up the groundwork with my services and my middlewares. And now it's time for me to get into the fun part and actually start annotating some of these APIs. So here I've got that get all jobs endpoint that we were just looking at. I've got the version that returns a JSON payload. And I'm going to go ahead and add some of the documentation that this endpoint needs. Now, if you're familiar with building controller-based apps, you probably are familiar with using the produces attribute to document your APIs. You'll notice here that I'm using the extension methods that are coming in with minimal APIs to document the API. If you want to use attributes, those will still work, but I prefer the extension methods. It reads a little easy on the eyes. So here what I'm saying is that my getAllJobs endpoint is going to produce a list of jobs with a 200 status code. That makes sense to me. I'm uniquely identifying this endpoint as a getAllJobs endpoint, and then I'm tagging it as one of the many getters in our application. We've got a few of those that we're going to see in just a little bit. Now, similar to what was supported in MVC, in addition to having one produces attribute, you can have multiple if you want to convey something like an endpoint that can return a 404 if it didn't find any data in your database, or an object if it did find something in your database, which is what I've done here for my getJobById endpoint. You see I've got two produces, one for the 404 and one for the 200 OK. Pretty nifty. Now, getters are fun and nifty, but we've also got endpoints that take in data. And an example of this is this postJobs endpoint that I have. Now, this postJobs endpoint accepts a jobs DTO, and I want to go ahead and document that. So I'm going to show you what it looks like to annotate and say that a particular endpoint accepts a certain type of endpoint as data. And as you might expect, I'm using the accepts extension method to say that this endpoint is going to take a job DTO, and it's going to consume it as a JSON payload. So there you go. We've got accepts to define what our post-based endpoints consume or take in as input. And of course, produces with name, get tags, all of that fun stuff. Now, last but not least, let's talk a little bit about endpoints that we don't want to be documented. So we've got this search by query endpoint that I'm kind of wanting to omit. I was just playing around with something, and I don't want this to show up in our OpenAPI description. Well, I can use the exclude from description marker to say, wherever we're generating an OpenAPI specification to document this API, just omit this endpoint. And what does that all look like when everything is said and done? I'm going to hop over to my browser and show you. So we're going to go here, and you'll see that I've got the Swagger-based UI. I have got my creators, which was that postJobs endpoint, under one category, and I've got my getters under another. We can pop in and see that it's been documented that our postJobs endpoint is going to take a JSON-based object that contains the ID, latitude, longitude, and name of the object that we want inserted into the database. Pretty cool. And we can actually try and execute against some of these endpoints from the Swagger UI. But I'm not going to do that exactly because I've got an even better idea, which is I want to take a stab at building a user interface for our application here. Ooh. And I'm going to do that by leaning into one of my favorite UI technologies, which is Blazor WebAssembly. Woo! So through the power of preparing ahead of time for my demo, I have set up my application with a Blazor interface. And I'm going to show you some of the changes that I needed to make to my program CS in order to support hosting Blazor. Now, if you're starting off with any of the templates, you're not going to need to make any of these modifications, but they're helpful to know about. So here I am registering the services that enable Blazor WASM hosting, same model that I did with OpenAPI. And the next thing I'm going to do is show you all of the middlewares that I'm registering in order to be able to serve all of the static assets that are associated with my Blazor WebAssembly application. And when all is said and done, I'm going to give you a sneak peek of what I've built, which is right over here. Sweet. So I have used a map-based UI to lay out a map of all of the points that are currently in our database. You can see we've got all of the different job sites that have been registered displayed on this wonderful map. And I'm going to show you a little bit of what that looks like from the Blazor end behind the scenes. And you'll be happy to know that it'll look pretty familiar. So if we hop over to our index.razor page, which is the home page for our application, you'll notice that I'm using the HTTP client to send a JSON request using a GET to the jobs endpoint that we were just looking at. And I'm going to take the result of that request and populate it into a list of jobs stored locally in my Blazor WebAssembly application. And then I'm just going to display those jobs as map markers in my UI. Now, getting data from a database is pretty nifty, but I want to show something else, which is sending data to the database. And what I want to do is add a feature that when a user clicks on a map, they're able to add a new job site. I think that's going to be really helpful for some of our workers. And I've done that here. I have my onMapClick event handler. And what this is going to do is it's going to take the information about the current latitude and longitude that was clicked on the map, the name that the user has picked, and it's going to send that as a post request to the API that we're using. And it's going to add it to the database behind the scenes. So let me show you what that looks like right now. I'm going to pop over back to my UI here. Let's go ahead and add a new site, let's say in Kennewick. And I'm just going to call it Kennewick Apartments because developers are not known for creativity with names. Cool. And we'll see that it's been added to our UI. And if we refresh here, we should be able to see it also added into our map. So that was pretty nifty, don't you think?
I think so, but are we just letting anyone add job sites?
Good point. We should probably add some sort of security or authentication into our application. Now, let me show you how to do that. And we'll start in the same framework. We'll talk about the changes that I'm going to be making to my minimal app, and then some of the corresponding changes in my Blazor application. So I'm going to hop over to my program CS here. And you'll notice that I've done a couple of things. First things first, I've registered all of the authentication services that I've needed using an Azure AD-based configuration in my app. So I'm using Azure AD and Microsoft Identity Web to provide authentication in my application. The other thing I've done is I have registered all the way at the bottom the use authentication and use authorization extension methods to add in all of the authentication and authorization related middlewares into my application. So with those two things, I've been configured to support requiring authorized access to particular endpoints. The endpoint that I care about locking down is the require authorization endpoint, which is right here, or the post jobs endpoint, which I've already added the require authorization extension method to. Now, if you've used controller-based applications, you might be familiar with the authorize attribute on an action or controller. This is the exact same thing. I'm saying that if you're going to be sending a post request to jobs, you better come with a bearer token.
Could I use the authorize attribute if I wanted to?
Yes, you can. Ooh, flexibility. I love it. Cool. So now that we've got the logic written up in our backend that requires authorization to our endpoint, we're going to go ahead and modify our front end a little bit. And this is all done in Blazor. And it's actually pretty nifty to do. All I've done is added a try catch to my post request that says, try and send a post request. And if it fails because there's no access token that the user has registered, then go ahead and redirect them to log in. So let me show you what that looks like. And I'm going to do that in my hidden window here. So I'm not logged in. I'm in incognito mode. I should not be able to add any endpoints. And I'm going to try and do that right now. Now let me call this hacky endpoint because I'm a hacker. And you're going to see that I am prompted to log in via Azure AD into my application. And to save time, I'm not going to do that here. Also, no one needs to know my password out on the internet. So I've already actually logged in to this app that I've had running before. You can see that I've got my user account already registered, and I'll show you that if we try and add here, let's call this Nez Purse Apartments. Nifty, we're able to add the endpoint now, and we've actually done it by providing a bearer token in that outbound request we sent from the client to our minimal API server. It's pretty neat.
commentary.
I like the track that you've set me down with making sure that my fundamentals like security are covered in my application. I think there's one thing we want to do before shipping this out to production, which is making sure that we test our app. So I'm going to jump in and talk a little bit about testing minimal apps in .NET 6. Now, there's two ways you can test minimal apps in .NET 6. And I'm going to start by talking about how you can approach integration testing for minimal apps. So I've created a new test project, and I have this integration test class. And I'm using this class to validate that my much beloved post-jobs endpoint works the way that I might expect it to. And this is a basic three-step test setup. I'm going to create a new API application. We'll talk a little bit about what's under the hood of this API application here in just a second. I'm setting up some data that I'm going to be sending, which is this test job. And I'm sending out what I expect is to be the response body, which when we send a post request with a job, we're going to get a response containing the information for that exact same job. Now in Act, I initialize an HTTP client associated with my application. I send that post request with the job that I created. And then I read the response and assert on the status. So I should be getting a created status code, which is what our post endpoint returns. And I should be getting a string containing the JSON representation of the job that I tried to insert into the database. So cool, nice test setup here. What is API application? Well, this integration test is leveraging the Web Application Factory infrastructure. So here I've got this API application, which is an implementation of a Web Application Factory with a little bit of bootstrapping done under the hood to support using an in-memory database instead of the Azure SQL database you were talking about a little bit earlier. And also to support Azure AD, instead of supporting Azure AD authentication, we're actually using a test auth handler. So instead of having to go to the cloud and hit the end-to-end and all that, I'm mocking out a little bit of the external factors in my application. So that's integration testing. Now, it's a little bit heavy duty. After all, you have to test all of your middlewares and services or mock them out if you're not able to. And you're actually running an application server in memory in your app. I wonder if I could try something a little bit more lightweight. And it turns out that I can actually. And we can do this by leveraging unit testing for our application. So I've gone ahead and I've created a unit test class here. And this unit test class is a typical unit test class. I've done some stuff to set myself up for success here though. I've created this job service, which contains all of the endpoints that I initialized in my application. So I've got get all jobs, which we've been talking about quite a bit. We've got get job by ID, create job. All of these have been factored out into core methods. So all of my business logic is in this job service, and this is what I'm going to be testing in my application. So how do I test it? Well, pretty much the same way I showed you earlier with a few changes. I'm going to instantiate a job service instance, act by invoking the business logic in the create job method, and then I'm going to assert on the result type that is returned from that. So we can see here that I'm asserting that it's returning a minimal APIs extensions result type with the status code that I expect, which is 201 created, and the expected value. Pretty neat, huh?
Yeah, but I don't think I've seen that created type before. Did we sneak that in right before release?
Ooh, you have got a sharp eye, Stefan. So Stefan is pointing out this minimal APIs extensions results type that I'm using to assert that my create job endpoint returned the right thing. It's not that iResult type that we were talking about a little bit earlier. Turns out I'm leveraging an ecosystem library here to make it a little bit easier to test out endpoints that return iResult objects. There were some gaps in the initial iResults API that we're planning on addressing in .NET 7, and this extensions library takes care of that. So that's why I'm leveraging it. Makes my unit tests a whole lot easier to write. Now you've set me on a pretty good track, Stefan, which is talking about the future of minimal APIs in .NET 7. We've talked about all of the things that minimal APIs currently do. Open API support, Blazor integration, auth integration, and support for integration and unit testing that we're going to be continuing to improve. We've got more coming up in .NET 7, and we want you to help us build it out. And the best way to do that is to start playing with minimal APIs and using it to build your applications. You can check out the official minimal APIs docs at the links here and check out some of our sample apps, including the demo code for this app. and share your feedback with us on GitHub.